Steve.
All right, very good, everyone. Thank you all for attending. Let me just share the agenda. I have been slacking lately. I posted the agenda like 2 minutes before the meeting. I sincerely apologize, but let's see. I'm just going to share my entire screen. This is the agenda today. I also apologize that I have not had a chance to post the last week's minutes. So we will revisit the prior last week's minutes next week. So next week we will approve 2 weeks worth of minutes if that's okay with everyone. Again, I apologize. I've been at RSA conference all this week, and my time has not been my own. Doesn't look like there's any new folks on the call today. I think everybody's been here before. So with that, let's go ahead and get started if we can. Last week or last time, 2 weeks ago, I guess, we left off on release notes. This very briefly is a way to essentially digitally transform the publishing of release notes. Surprisingly, there's not a common format to actually do this. Release notes are typically captured in Markdown, HTML, PDF, Word documents, text files. There really isn't a standard. And in a lot of cases, the release notes are available in multiple formats. So what we wanted to try to achieve here was to be able to provide a common format to capture release notes so that you could create publishing processes to take this machine readable format and put it into Markdown or HTML or PDF or use on social media, for example, in a common format. So that's kind of the intent of this part of the spec. So we're going to go through this fairly quickly, if that's okay. There's not a lot of, most of these things are very self-explanatory. So let's start with the type. This is the type of release notes. Major, minor, patch, pre-release, or internal releases. The title of the release, that's a string. We've got the featured image. This is for publishing. Again, this is a URI to or URL to the image itself. This is the URL to the image to be used on social media. Description of the release notes, a timestamp of the release note when it was published, aliases for the release itself. For example, you might have 1.0 of something, but that 1.0 might have been called, I don't know, Project Mars or something like that, right? It might have multiple names, especially when something was early in development. That is an array of strings. We also have tags. Now, these tags are a little bit different from the tags that we have on components themselves. So components themselves can have a tag. The tags on release notes essentially overload the one on components. And this is great because now you can have SEO specific tags without, so SEO, search engine optimization. You could have tags that are specific to SEO that you may not want to include in the component itself, right? In the component itself, those tags are going to be more factual versus the tags here that, again, are going to be used for discovery of software that you know has these specific tags.
I wanted to quickly
Yeah.
ask a question about tags. I don't know if it was covered when you did tags on components. Um, if you were to use like the GitHub universe definition of tags in like the release notes zone, tag has like a really specific term as in like git tag. Yeah, I guess I'm just saying like there's a potential here for confusion, and so it might be valuable from an editorial perspective to say this is not the Git tag.
Right. Yeah. Get tag. I mean, these are tags for like hashtags, right? Right. That's
Sure.
essentially what these are.
I definitely understand the goal. I could imagine in the interest of attempting to automate this that the name conflict
Got
could
it.
be.
Is Jan on the call or no?
It's a holiday in Germany. He had
Oh,
mentioned
that's
it
right.
was
It is. Okay.
on. Yeah.
Let me let me take a note of that then. Um,
Yeah, I totally get what it means, and I think in the real
yep.
world the naming conflict exists, so it's fine. But depending on like what context window you're approaching this from.
Got it. Okay. Good call out. All right. So a given release can then resolve certain things. So in this particular case, it can resolve a number of different things. So these are the different things that the fields for resolves, and we'll go through each one of these one by one. This is the type of issue that it's resolved, defect enhancement or security issue. I think we've actually gone through this before. This was part of the pedigree. But these are the exact same fields that we've talked about previously when you, in the pedigree section, where the pedigree can describe what the changes have resolved. Well, this is basically the same thing, except for the release notes themselves. So this is the ID, this is the name of what the issue was, a description of what the issue is. This is the, who's providing the source material for this, like, is it Acme Incorporated? Is it, Microsoft, some other organization? Let's see, URL references. Okay. Oh, that's the URLs for each. Okay, so this is the notes themselves. The notes themselves are multilingual. So you can have the exact same release notes available in multiple languages. So here we've got the ISO 369 locale. So this is going to be like EN or EN US, FR Canada, for example. And then you actually have the text that matches that particular locale. So this is all kind of wrapped up in an array. So within this notes array, you basically have an object that specifies a locale and then the content of the release note itself. Okay, and then the content, just like all other forms of attachments, you can have an optional content type, encoding, and then of course the content itself. So if you wanted to base 64 encode something, you could theoretically do that. You could specify the content type, for example, text / plain. Obviously, you could do markdown, you could do a Word document, whatever it is that you wanted to do. There's the base 64, and there's the content. And then, of course, like all other CycloneDX properties, or a lot of them, objects, there's the properties array, which is that name value pair. And I think that concludes the release notes. Yeah, that concludes the release notes. On to the ML stuff. This was new as of 1.5. I actually did a presentation on this at RSA. Two presentations, actually. There was one on AI BOM specifically, and then OWASP had a hour-long talk on beyond SBOM. So it was incorporating SAS BOM, AI BOM, and CBOM cryptography. So within a CycloneDX component, you can have an optional model card. We've essentially standardized the way model cards are represented. We have modeled this over after the TensorFlow model toolkit, along with Verify ML. Verify ML is also based on the TensorFlow model toolkit, which itself is Apache 2 licensed. And so ours kind of is a very similar kind of approach to that, but it extends it in many ways. So like all things, like
Yeah,
a lot of
I'll say it wasn't limited to that. So I mean, in terms of, I actually surveyed and we talked about, we actually did looked at Amazon SageMaker, we looked at Hugging Face, looked at a plurality of things, but TensorFlow is definitely the basis. But we represented a larger spectrum, I think. Just to let everyone know that. So anyway.
yeah, absolutely. So here's the bomb ref. So this is the unique object or object identifier of the model card. And then we've broken it down into three big buckets of things. We've got model parameters, quantitative analysis, and considerations. And these are well, the model parameters and considerations are fairly decent sized objects. Quantitative analysis, there's really only two things in there: performance metrics and graphics. And then, of course, we've got properties. But in the model parameters, we have the approach. We've got the task, architecture family, model architecture, the data sets, and the input and output formats. So let's go through each one of those. So the approach itself is an object, and we've got the approach type, which is a enumeration. So you can specify whether it's a supervised, unsupervised, reinforcement learning, semi-supervised, or self-supervised model. You can specify the task that it performs. So this is just a text field. So for example, you might have examples of like classification or regression or clustering, for example, as task. You have the architecture family. Again, this is an optional string. So you might have a task such as transformer networks, neural networks, residual neural networks, etc., as task types, or architecture family, sorry. You've got the model architecture itself, like ResNet 50, YOLO, and then you've got the data sets. Now, the data sets can be, this gets a little bit more complicated because you have a choice of doing either inline data or using a reference. The inline has some limitations, so we actually recommend, in most cases, organizations choose this option. Now, there are some use cases for doing the data inline for very, very simple models, especially when the model and the software for the model is essentially the same thing. However, in most cases, that doesn't meet most organizational use cases, so people would prefer the second option. So for the inline, if you're specified in the data set inline, again, you've got the BOM ref, you've got the type of data set, you've got the name of the data set, the contents, obviously, data classification, whether or not it has any kind of sensitive data like PII, for example. You've got some graphics that kind of describe what the data is, description, and any data governance fields. So let's go through one of these. Let's go through these now. So the type is going to obviously, in this case, be data set. And then you've got the name of the data set. This is a string. You've got the contents of the data set. Again, this is going to be either the attachment or a URL. Then, of course, you've got properties. If it is an attachment, this is the object. You can specify the content type, the encoding, and, of course, the content itself. You've got the URL to where the data resides. So if it's just too big to inline, you can just say, here's where the data is. Let's see. Oh, that's the contents. Those are the properties, right? We'll skip properties. Data classification. So all data can have, obviously, a data classification. So this might be public, or it might be customer confidential, or something like that, right? A description of the sensitive data. So for example, you might have a data classification of customer data, and then you might, in the sensitive data field, you might actually have, something like PII or PHI or something like that, right? Graphics collection. This is really about the metrics. This is really about the metrics. So the unfortunate reality is that there's so many different types of ways to do performance metrics and other kinds of metrics that it's nearly impossible to create a machine readable format to be able to capture it all. So what TensorFlow Model Toolkit and what we did is we just said, here's a graphical representation. No matter how simple or how complex your data is, you can represent it graphically this way. We've got a description of what those graphics are, and then the images themselves. So each image has a name, and then of course the image itself. Let's see, the image again, the image data itself, again, you're going to be having a content type. So it could be, you know, a JPEG or PNG, that would be the content type, right? If you optionally wanted to encode that, base64, for example, and then of course the content for that. Data governance or description, I guess. This is a description of the data set. All data sets do have a description. Data governance, this is really about the custodians, stewards, and the owners of the data. They could theoretically all be the same role, but in many organizations, because of separation of concerns, these will actually be different people, different roles. So CycloneDX for all data, for all types of data, not just model cards, but for all types, we support all three of these fields. For each one of these, so custodians, stewards, and owners, for each one of these, you have a choice. And that choice is either an organization or a contact. And we've talked previously about the organization as well as the contact. You'll see here in a minute. For example, here's the organization, which has a name, address, URL, and of course the contact, right? And then of course the individual's got, you know, their name, email address, and that sort of thing. So I'm going to skip all this because we've talked about this many times already. Let's see. Where am I now? Organization contact, country, locality. Okay. Okay, here we go. All right. So if the data set was not inlined, meaning that, you know, in most cases, you're going to use a data component to describe your data. Well, this is basically the BOM ref to that data component in your BOM. So this is what most organizations are actually going to do. This will actually be spelled out a little bit better in the authoritative guide on AI ML BOMs as well. For inputs, this is kind of the input to the model. For example, you might have a text to image, or you might have a text to text or text to speech, for example. Well, the input in this case would be text, right? The let's see. So this is just a string. So if I'm supplying text to like a prompt, for example, that could be a string. And then of course the output. What is the output, right? I might also output a string, but I might also output maybe an image or you know, an audio file, or in some cases I might output multiple things, right? So you can capture both the inputs and outputs for the model. The quantitative analysis, this is that second group of big things within the model card. Very simple. As I mentioned earlier, performance metrics and graphics. Performance metrics, it's fairly basic. We tried to capture as basic information as possible. We've got the type, the value, the slice, and the confidence interval. Let's see. The type is simply just a string. the value, of course, of the metric. We've got the slice, which is the name of the slice of this, assume this metric was not sliced. I am not an AI person, but supposedly data scientists actually understand what this means. If we want this spelled out a little bit better in the Ecma documentation, I'd be happy to get some AI folks back in and provide a better description if that's what the group would like.
I would support that.
Okay. Okay, confidence interval. Again, I will do the exact same thing here because it looks like the description is kind of vague. I'm just taking notes. Upper and lower bound for confidence intervals. Graphics collection. So a description of the collection, and then of course the contents of the collection. If we go into the contents of the collection, we basically have, again, a name of an image and the image itself, right? And then of course the image itself, you can have the content type encoding and the content itself. Let's see. Considerations. This is the third big bucket of what's in a model card. Who are the users of this particular model? What are the use cases the model was intended to serve? What are any kind of technical limitations, performance trade-offs, ethical considerations? New in 1.6, thanks to IBM, is environmental considerations. And then, of course, fairness assessments. So if we look at the users, this is an array. Who are the intended users of the model? What are the use cases of the model? Again, this is an array of strings. What are the technical limitations of the model? Again, an array of string. Let's see, trade-offs, performance trade-offs. What is it? What are the things that it excels at versus the things that it does not? How does it balance the performance versus the accuracy, for example? What are any ethical considerations? And every ethical consideration, this is an array of objects, but the ethical considerations can have a name and then, of course, a mitigation strategy. So what is the name of the consideration? It could be it could be race, religion. It could be biased on any other kind of concern. And then what are you doing about it in the model or in the software around the model? What are the environmental considerations? We went through this briefly with when Matt presented this. So this is really about the energy consumption. So let's see, energy consumptions is an array. And then, of course, you have the activity, the providers of the energy, the cost for that energy, the CO2 carbon emission, cost equivalence, cost offset, and then of course we have the properties. So let's look at that first object, which is the activity. The activity has a design and data collection. This is an enumeration. So this is the activity. This is the activity, and you have a choice of either. Okay, so this is more workflow. This is life cycle. So in design, data collection, data preparation, whether it was in training all the way to inference. Who are the providers of the energy? Again, this is going to be an array. And this is the same object that we've been looking at previously where we're describing the organization. But this has been added to also include the, this has been enhanced to also include the source provided and, of course, external references. Let's see, what's this? Energy providers. Okay, so this is the unique identifier. This is the BOM ref of the provider itself. This is a description of the provider. This is the organization. So again, it's a name, address, URL, contacts, that sort of thing. So I'm going to skip by all this. Okay. Okay. The energy source itself. And then this again is a string, an enumeration of a lot of different choices here. Everything from coal to biofuel and lots of stuff in between. The energy provided. This is an object with a value and a unit of measurement. So the value is the number, and then the unit is defaults to kilowatt hours. And it looks like that's the only choice. So this must be set to kilowatt hours.
And that's consistent. We talked about that's a number in the JSON, so it can, well, it's that, I mean, the value is a number, so it can is a float, basically a decimal. So you can represent
Right.
it. So this invites comparison. So the goal is people will come on and compare one model's energy cost to another's. So normalizing it makes sense.
Right. So you combine these two things. This could be 1.0, and this is could be, kWh. So that would represent 1 kilowatt hour. So very simple. External references, I will skip that. Activity energy cost. Let's see, the total energy cost associated with the model lifecycle activity. Okay. So we talked previously about the activity itself, everything from training to inference and everything in between. So we can have different costs for different parts of the lifecycle, which is amazing. Let's see, this is the value itself. And again, we've got the unit, which is kilowatt hours. CO2 equivalent cost. This is really, really interesting. I was talking to somebody at the RSA conference about this. I think it was yesterday as well. So again, we've got the value of measurement and we've got a unit. In this particular case, the unit of measurement is a little different because we're not measuring energy, we're measuring CO2 equivalents. So this is tons of carbon dioxide equivalent. So that's kind of what that value represents. So that's the only choice for the unit of measurement. Cost offset. Quantity of carbon dioxide and the unit of carbon dioxide. So again, this is going to be a number, and we will have the same unit.
Yeah, I'll just clarify, neither of these things are repeated. So if you look at the schema, it's just the spec, expands the underlying type. So it's the same definition for CO2 measurement and energy measurement. They're the same. It's anyway, just explain. They're not, if you change it in one place, it changes everywhere. So
Yep. Awesome. Properties, which is the name value pairs. Okay, we have the fairness assessments. So this is an array, and within that array is an object that can contain various other things, such as groups at risk, the benefits, harms, and the mitigation strategies. So the group at risk, this is the groups or individuals at risk of being systematically disadvantaged by the model. The benefits of the model, the harms of the model, both of those are strings. The mitigation strategy, what are we doing about it, if anything? Then again, that's a string. And then we have the properties. So we've seen properties before. Okay, that's it for the model card. The CycloneDX also has a data component. So there's a type of component called data, And if you have a type of component called data, there is a place for you to describe that data. And that's what we're looking at now. So that data object, again, it's going to have a BOM ref. It's going to have a type of data. So not only does the component have a type, but the data also has a type. A name of the data, the contents of the data, data classifications, sensitive data, graphics, description, and the governance. We've seen governance before. We've seen classification and sensitive data and graphics and description before, literally in the inline part of the model card, where you can inline part of that data. Well, that was essentially these fields right here that we just talked about. But for a data component itself, you can have different types. So one type is that we can represent source code, right? So if you've got source code that you've grabbed from Stack Overflow or some other random kind of place, right? You can describe this code snippet in CycloneDX. You can describe configuration. This is really, really useful for operational bill of materials, right? The SBOM describes what software you have. You might have an OBOM, then describes the runtime environment. For example, maybe you've got it running in a container, or you have the software running on a piece of hardware. Well, you can describe what that runtime environment is, including any configurations for the system or for the application. We've got a data set. That's another type. Definition, which is primarily used in formulation, but it can be used in other places as well. And then if something that doesn't really fit, the mesh, just use other. I'm going to skip through a lot of this before because we've already seen this. So this is the inline attachment. If you choose to do that, obviously you can do, you can attach the data. Obviously, if you're attaching source code, this is fairly simple. So you can, you can include the code snippet. It's fairly simple. Obviously, if the data is like from machine learning model, obviously you don't want to inline, a terabyte worth of data into a JSON. That's just doesn't work. So you have a way to provide the URL and other information about that external data. This is the URL, for example. Let's see. We've seen all this before. Sensitive data, graphics, collection. Yep. The image, encoding. We've seen all this before. Data governance, custodians, stewards, owners. We've seen it before. Oh yeah, this is going to get long again. Okay. Governance. Okay. Okay. So just like we had, a type of data component, well, you can also have a cryptographic asset as a component type. And if you have a cryptographic asset as a component, you can describe the cryptographic properties of that component. And that's what this object is all about. So within the crypto properties, this is a fairly big object, by the way. We have the type of asset that it is. We have the algorithm properties, certificate properties, or related crypto material properties. And depending on the type of asset, you're going to use one of these three big buckets, either algorithm, certificate, or related crypto material, or protocol properties. One of these four, sorry. So the asset type itself could either be an algorithm, a certificate, a protocol, or related crypto material. So all four of those align to the properties for that you can describe for that type as well. So if we look at the algorithm properties, for example, if the type is an algorithm, then here are all the different properties I can describe about that algorithm. I can describe the primitive, the parameter set identifier, which is like AES 128. So this would, in that case, it would be 128 is the set identifier. I can supply the curve. We originally wanted to make this an enumeration. However, and there's actually a really good list of curve names over here. Unfortunately, after talking to the PhD student that put this together, which was a ton of work, by the way, some of the curves exist in the real world. Some of them only exist in research papers. And the curve names, in a lot of cases, are not authoritative. So we really didn't want to put non-authoritative curve names into the spec, knowing that this was going to be a future ECMA standard. So right now it is a string field, but we're essentially encouraging folks to adopt the curve names that are outlined at these URLs because they've done a really fantastic job of doing that.
Yeah, I think that the acknowledgement is that we want people to get crypto information in as quantum algorithms are developed, and they're all experimenting with different types of curves that go in and out of vogue until some are solidified and recognized by FIPS.
Yes, absolutely. The execution environment, implementation platform, certification level, this refers to like FIPS or CC, common criteria, for example. The mode of operation, padding, crypto functions, the NIST classical security level and the NIST quantum security level. Both of those are being captured. So if we look at the first one, this is the primitive itself. If you're not a cryptographer or into cryptography, a lot of these things are not going to make a lot of sense. But we tried to provide as good as description as possible. So the first choice that you have in the primitive, which again is a string, this is an enumeration of possibilities, is a deterministic random bit generator. You've got the MAC, message authentication code. You got a block cipher, a stream cipher, signature, hash, PKA. This is the XOF. I always want to say XOR, but it's not XOF. KDF, key agree, CHEM. What does AE stand for? Authenticated encryption, combiner, other or unknown. The combiner is really interesting and seems to be very popular with quantum safe algorithms because you're actually combining different primitives into essentially one. So that's a really interesting use case for quantum readiness. The set identifier. So again, like if I have SHA-256, the value of the set would be 256. This is the curve. Again, we are encouraging folks to use the curve names here. The execution environment. So we've got a choice of values here. Software plain RAM, encrypted RAM, software T, hardware, other or unknown. The implementation platform. So because different algorithms are going to have different weaknesses and potentially vulnerabilities depending on the platform. So we are capturing essentially all of the major platforms that exist. If something is not captured, you can specify other, or if you just simply do not know, you can specify that as well. Certification level. That is interesting. Why is, Oh, I know why. Okay. All right. Let's see. Certification level. Again, this was really designed to describe like FIPS or common criteria. So we got FIPS 140-1 level 1 all the way through level 4, and then FIPS 140-2 1 through 4. FIPS 140-3, 1 through 4. And then we've got the same thing for common criteria, right? 1, 1 plus, 2, 2 plus, all the way up through 7 and 7 plus. Then, of course, if there's other certifications, because there are, other countries that use their own that are either not FIPS or common criteria, you can specify that, or if you simply don't know, you can specify that as well. Let's see. This is the mode of operation for the algorithm. This makes a lot of sense if you're into cryptography. CBC, EBC, CCM, GCM. What is this one again? Oh, CFB, OFB, CTR, other, and unknown. Padding. PKCS5, PKCS7, PKCS1 version 1.5. OAEP, this was a new one as we were developing the standard. Raw, other, and unknown. Crypto functions. This is basically, what does the algorithm do, right? So it can generate stuff. It can generate keys. It can encrypt. It can decrypt. It can do digest. It can tag. It can do I can't talk today. Sign, verify. What's that?
Derivation.
Yes, thank you. I cannot speak today. My God, I need more caffeine. Encapsulate, decapsulate, other, and unknown. Classical security levels. I believe this is, let's see, this is a NIST thing. The classical security level that the algorithm provides, and then the quantum security level as well. What is not in here is that one of these, I think, there is a min and max value. So those are not showing up in the documentation. So I will make a note to find out why the min and max values are not showing up in the documentation. Okay. Made a note of that. I know one of these goes up to like 10, for example, and the other one doesn't have a limit, but I think it starts at 1 or 0. So
Yeah,
I'll figure.
I think there are a lot of constraints that are not. I mean, I think most constraints are not listed. I think that's just the way the level of which the documentation was produced from schema. So,
Yeah, I think so. This one's got the maximum levels. This one ends at 6. The other one, I'll have to look into.
the other one just has minimum 0. I could paste it in the chat, but anyway.
Oh, okay, perfect. All right, so that's not showing up then. Okay.
I was just pointing out there are a lot of other types of constraints that are not easily capturable in documentation form.
Yeah. Okay. I'll take a look at that, Matt. All right. So if the crypto asset was a certificate, then you can specify the properties of the certificate, which is what this big object is. Let's go down through each one. We've got the subject name. Again, this is going to be a string. The issuer, string. Not valid before, this is going to be a timestamp. Not valid after, also a timestamp. And then we've got, let's see, this is the algorithm reference. So this is a BOM ref to the signature algorithm used by the certificate. So that's going to be another CycloneDX component in the BOM. Subject public key ref. So this is going to be the same thing. So this is, you're basically specifying another CycloneDX component, which is the public key that is then used by this certificate. And this is the reference to that public key. The certificate format, X509, PEM, DIR, CVC are the choices. certificate file extension. This is just a string field, but these are some common examples that you're going to see in the wild. If you have a component type of related crypto material, it's funny because a lot of different types of cryptographic materials, they all kind of share the same fields. And there's actually a really good illustration. You know what? There's a really good illustration that I use in one of my slides. I think I'm going to put that illustration in here, and that way we'll have a figure to kind of graphically represent the related crypto properties. So I'll work on that.
Yeah, I'll just say discussion was there's a lot of discussion around in terms of content protection schemes based in cryptography. There are a lot of things that are used. Like I said, combiners is one that is being exposed, but in terms of special padding mechanisms, that's covered by other potentially. But there's things called every scheme has what's called a black book. And that's where you can describe these things basically if you choose to do so. What salts do you use? How do you maybe create combinatorial keys of some kind on a per message basis for streaming packets. How do you pad your packets differently? How do you put headers or trailers in your packets for verification purposes, etc.?
Yep. So this is the related crypto material. This also has a type. We're going to talk about all these. So let's, this is the type. Okay, so this is the type. The type is also an enumeration. So you've got private key, public key, secret key, a generic kind of key, ciphertext, signature, digest, initialization vector, nonce, seed, salt, shared secret, tag, additional data, password, credential, token, other, and unknown. So lots of different types of crypto material that are categorized in this related crypto material type of asset. So we've got the ID. This is not the ID like a bomb ref or anything like that. A lot of these types of assets will have their own special ID. So this is an ID specific to the crypto material itself. The state, so these are defined in NIST SP 857. So these are the states that NIST 857 actually supports. Pre-activation, active, suspended, deactivated, compromised, and destroyed. The interesting thing about these states, they can be used in combination with CycloneDX life cycles. So theoretically, you could describe something that is, for example, a SBOM and a build life cycle that is using a signing key that has been compromised, for example. So these are like you combine these two different approaches, and suddenly you have some really, really interesting use cases that you can do. Let's see. This is the algorithm that is used to generate the cryptographic material. So the algorithm itself will be another CycloneDX component. So this is the BOM ref to that component. The creation date, which is a timestamp, the activation date, which is a timestamp, the update date, which is also a timestamp, and the expiration date, timestamp. The value of the cryptographic material, the size in bits of the material, the format, for example, PEM, DIR, etc. Secured by. This is the mechanism by which the cryptographic asset is secured by. So we've got, this is an object. That object contains two properties, a mechanism, and then the algorithm ref, which is the BOM ref to the algorithm in another CycloneDX component. So the mechanism is specifies the mechanism by which the cryptographic asset is secured by. For example, if you have an HSM, what does HSM stand for again? Hardware.
Yeah, don't ask me. No, you're on the right path. Yeah, so
Yeah,
hardware,
it's a
hardware,
dedicated black box.
hardware security mechanism. I think that that's a nice wave of the hand for a lot of things that we referred to, like the TEE stuff, trust execution environment, stuff like that. TPM
Right,
is
right.
so these are the higher order acronyms. But it's more, that's why it's a free form field. More or less it's a string. So anyways, they're
Yep,
examples, not an enum, because these are we can't describe everything, right?
exactly, exactly. All right, so HSM, this is very, very popular. It's kind of a black box that you say, hey, I just want to do something. I want to get a key. I want to sign something. Your HSM does that. TPM, SGX, it's just software, for example. So these are just examples that Matt said. And then, of course, this is the algorithm ref. So this is the reference, the BOM ref, to the other algorithm, which is another CycloneDX component. And let's see. I think now would probably be a good breaking point. We will pick up, I think, protocol properties next week. And HSM module, yeah. Okay, yeah, I think we've gone through a lot today. So thank you all for kind of bearing with me. We've got a lot more to go through. I would highly encourage everyone to kind of read through it and in advance. So if you have any specific questions on things, please reach out or address them in or we can address them in next week's call. But does anyone have any last minute things they wanted to bring up? And I think I put everyone to sleep.
You should have woken everybody up and said, "We're done."
It's released. Yay. But you're like, what?